When geologists try to identify rocks, they generally look at two things. The first thing we look at is mineralogy. That's what is the chemical composition of the rock, what minerals are in it, so on and so forth. The other thing that we look at is texture. That means how are the components arranged? What's the actual buildup? Now, as we look at some common textures of rocks here over the next few minutes, one of the things you need to keep in mind is that geologists love to make up words, and geologists have words for everything. And so any geology student of mine knows that you've got to learn a long list of words if you're going to be a successful geology student. But anyhow, I'll razzle-dazzle you with a few terms here. This is an igneous rock. It's called granite. And igneous rocks basically have one of two textures, the most common. This is called a phaneritic texture. And a phaneritic texture basically means that it has crystals in it big enough to be seen. And the normal guideline is you hold it out at arm's length. If you can see individual different minerals, you would call that a phaneritic texture. That comes because granite forms by slow cooling underground, and it develops large crystals. On the other hand, this igneous rock called basalt formed at the surface. The magma cooled rapidly. There wasn't enough time for crystals to form. We hold this at arm's length, and it looks completely uniform. And we call this texture aphanitic. So the two basic textures of igneous rocks are phaneritic and aphanitic. There's some others, but those are the most common. Now, if we look at sedimentary rocks, we have two terms here that are textural terms, but they're also relating to the origin of the rock. If we look at sandstone, which feels sandy and gritty, and if we look at shale, which is more of a smooth nature, both of these are what we call either clastic or detrital sedimentary rocks. Clastic comes from a word clast that means particle. Detrital comes from detritus, which means an accumulation of sediment. Both of these sedimentary rocks have particles in them that came from pre-existing rocks and were transported generally by water, accumulated in the ocean, and then ended up back in a rock again. Now, not all sedimentary rocks have particles in them, and so we call those non-clastic, sometimes called chemical rocks. Limestone is an example. Even though it looks like it has chunks in it, limestone actually comes from precipitation of dissolved calcite in the ocean, which then settles down to the bottom, accumulates together, and ends up in a rock. As we look at metamorphic rocks, we have rocks that have been affected by heat and or pressure after their formation. So we can take an igneous rock and metamorphose it. We can take a sedimentary rock, metamorphose it, and we'll get something new. And one of the things that we will sometimes see in a metamorphic rock is called foliation. Foliation means that the grains are aligned, generally due to pressure that the rock experienced during metamorphism. So if we see grains that are aligned like this in stripes, bands, we say that we have a foliated texture in the rock. Not all metamorphic rocks have that. For example, here's marble. Marble is metamorphosed limestone. And in marble, we look at it, we don't really see any stripes or bands, so we say that's a non-foliated texture. So those are examples of some of the common rock textures in the igneous, the sedimentary, metamorphic groups.